Hello everyone, I am Suchita Mori. Welcome you all in the video lecture on the topic Integral Calculus, Gamma Function. Now calculus is the branch of mathematics focus on limits, functions, derivative and integrals. Mainly it has two branches. First is differential calculus and second is integral calculus. Integral calculus deals with the integration and applications for finding the area, volume, in physics, moment of inertia, in fluid mechanics also, then center of gravity and inertia in mechanics and so on. Now here gamma function. Gamma function is a improper integral. Now what is improper integral? An improper integral is a definite integral that has either or both limits infinite or an integrand that approaches infinity at one or more points in the range of integration. And this gamma function is mainly used in the probability and statistics as well as in combinatorics. In mathematics, gamma function is an extension of the factorial function. Now we'll see the definition of this gamma function. The gamma function is defined as gamma n. It is denoted by this sign. Gamma n equal to integration 0 to infinity e to the power minus x to the power n minus 1 dx, where this it is valid only for n greater than 0. These are the properties of gamma function. Now here we prove the property gamma 1 equal to 1. Now we apply here definition of gamma function. Then instead of n we substitute 1. Therefore here 1 minus of 1 equal to 0. This first term as it is here. X to the power 0 is 1. Therefore integration of e to the power minus x is e to the power minus x upon minus 1. Substitute the upper limit and lower limit, we get the value 1. Now next property, gamma n plus 1 equal to n gamma n, where n is greater than 0. There, in this case, we again apply definition of gamma function. Instead of n here, n plus 1. Therefore, we substitute the value here, n plus 1. This n plus 1 and minus 1 get cancelled. We get n only. Now, we solve this integration by parts, considering x to the power n as first function and e to the power minus x as second function. And then when we substitute the upper limit and lower limit in first term, we get 0 value. And here minus of 1 and this minus become plus. Here this n is taking outside. Then this integration is gamma n. Therefore, we get n gamma n term. Now, for this property, here n is non-negative integer, then gamma n plus 1 equal to n factorial. Now we know that by using the second property, gamma n plus 1 equal to n gamma n, again we apply same property here. Therefore n minus 1 into n minus 1, gamma of n minus 1 here. Then again apply same property. Therefore here first two terms as it is here, then n minus 2 into gamma n minus 2. In this way, we continue this process till the end of the terms. That means up to 3, 2 and 1. Now this value 1, 2, 3 up to n, this is the n factorial. Therefore, gamma n plus 1 equal to n factorial. Now we solve some problems on this gamma function. Evaluate integration 0 to infinity e to the power minus 4x into x to the power 3 by 2. Now here we first substitute this 4x equal to t, because here we convert this term into the definition where e to the power minus of x term. Instead of the here 4x term, therefore we substitute 4x equal to t, then we find out the value of dx, so find out the limits for t. Here the limits are same, 0 to infinity e to the power minus t. Here x value is t by 4 to the power 3 by 2 and dx is dt by 4. We simplify these, combine the terms, taking constant term outside, and then here apply the definition of gamma function. Here, this is the definition which is given in equation 3. Now, n minus 1 equal to 3 by 2. Therefore, we easily find out the value of n equal to 5 by 2. Therefore, this is the constant value. Gamma of pi by 2 is 3 by 2 into 1 by 2 into root pi. After simplification, we get this is the answer, 3 root pi by 128. Now evaluate this integration 0 to infinity e to the power minus x square into x square dx. Again we consider this value. Here substitute this value x square equal to t. Then we find out the dx value. Then limits for t. Now here 1 by 2 integration 0 to infinity e to the power minus t into t to the power 1 by 2 dt. By definition of gamma function, we compare with this and write down the value of n equal to 3 by 2, and we know that gamma of 3 by 2 is 1 by 2 into root pi. After simplifying the terms, we get root pi by 4. Now show that integration 0 to infinity, this value equal to gamma n upon k to the power n. Here compare with the definition. Here this value is extra here, therefore instead of this we substitute t. Kx equal to t, find out the value of dx and find out the limits of t. After substituting here limits, we get this value here, 1 upon k to the power n is taking outside, this value is gamma n. We get the required result. Now for c is greater than 1, prove that this left hand side equal to this right hand side. Now for this we consider left hand side and put here c to the power x equal to e to the power t, because we have to reduce this in the definition of gamma function. Therefore now here we taking log on both sides. Here x log c equal to here t, and then we find out the value of x t upon log c, then dx and limits for t. Substitute all these values here and then taking constant value outside the integration, then remaining term is the gamma of c plus 1, and this constant value is log c to the power c plus 1, which is nothing but the right hand side of the given. Hence prove the result. Now for this, show that gamma n equal to this value. We substitute log of 1 by x equal to t. From this we find out the value of x, then dx and limits for limits for t. Here we substitute the limits. Here we taking this negative sign outside and then applying the property of integration. Therefore changes the limit 0 to infinity and remaining term is the gamma n. In this way, we solve the problems of gamma function. And here, next example, prove that integration 0 to 1, this value equal to gamma m upon n to the power m. Now for this here, first we substitute log of 1 by x equal to t as given in previous problem. Find out dx value and limits for t. After that, here we get this value, but here nt term. Therefore, for this nt we substitute z and another variable and find out the value of dt in terms of z and limits of z. If we substitute these values here, then taking a constant value 1 upon n to the power m outside, and this value equal to gamma m, and which is nothing but the right hand side of the group. Therefore, this left hand side equal to right hand side, hence proof. These are the practice problems. In these problems, we can substitute these values and find out the required result. Thank you.